Engineers love to deal in absolutes. We're trained for it when we study mathematics, electronics, and disciplines like finite element analysis or software development at university. And it seems to us like everything in the world can be reduced to ones and zeros, true and false. But business isn't like that. You have to prioritize, and it's a constant balancing act. Every time you choose to execute on that initiative, there's an opportunity cost. The time you spent on those cool infrastructure as code scripts, that's time that you did not spend delivering the incremental login feature that your customers needed. So how do you, as a technical leader, say a CTO, explain or even understand this balancing act and make sure that your startup or scale up survives? You can go to your engineers and you can say, never let the perfect be the enemy of the good enough. You can ask this question, are we focusing on our customers? You can say to your engineers, the practical solution that shipped is better than the ideal solution that didn't. But there's a level up that mastery tree, and if you as a startup founder are an engineer or you want to engage better with the technical competency in your startup, move up that mastery tree with the deeper knowledge that these ideas are not about compromising. There's trite aphorisms that leave engineers thinking they're being asked to lower quality to get a delivery out, and that runs counter to the engineering spirit. So great technical leadership understands that worse is better actually means that a worse, in inverted quotes, solution is actually sometimes a superior option. And that's a subtle distinction that I want to drill down to in this session. The compromising on quality argument is a complete red herring because quality is orthogonal to this issue of what a worse solution really means. Huh? Worse is better is not about quality? Well, what does worse mean then? A startup business is a business. So can't we just leave our engineers to do the right thing when it comes to building the tech that our startup business needs? But in a business, especially a startup, if the time that you're spending is gone in satisfying some engineering-driven pursuit instead of a customer need, pretty soon you're going to be dead in the water. Money burns away. It goes in no time flat when you're paying engineers. At your startup, think about it. Does resource-intensive technical tasks keep winning out over business realities on a daily basis? Startups can be fun for the makers, for the engineers. There's exciting moments. It's a chance to indulge those technical ambitions. But I have run several startup businesses, and when you have staff to pay, it gets real. So as a tech founder, you write code during the week, and then on the weekend you have to do payroll. People rely on their pay to get rent or mortgage payments and to keep their kids in school. So for those in technical leadership right now who may be scoffing and thinking, well, if you're out of money, then all bets are off. This has nothing to do with me. Have another look at what your technical decisions are costing. As a technical leader, as a senior engineer, for example, what could you do to reduce waste? As a startup, your cash burn rate and ability to make payroll is what gives you a runway, and that runway is a hard stop. If you are financially headed straight for the tarmac at 100 miles an hour, it doesn't help if your test code coverage is now 82%. Cash in the bank is the hard number that you cannot argue with no matter how much you love functional programming or lean code. Cash in the bank is the hard number you cannot argue with no matter how much you love functional programming or clean code. So how, as a technical leader, do you explain this to your engineers? How do you get this fact across that when the bottom of the barrel is reached, they don't get paid and the company has to shut its doors? Unless they've been through the experience of a startup or even a too big to fail company failure like Reality in Motion, the BlackBerry company, or the one that I experienced when I was at Nokia. That company shut so many offices around the globe. They struggle to wrap their brain around the idea. Engineers and engineering leaders feel like, if I just keep showing up at work, the tables and the chairs are here, the coffee machine still works, I still get paid, right? So there's a straw man of worse is better. That's an exaggerated form of an argument put up to try to defeat the argument. So worse is better is in fact a critical plank of senior engineering skill that you need to master in order to lead teams in a startup or an innovative business using tech. And it can help explain to engineers how to get on board with balancing competing priorities. But it doesn't mean compromising your ethical principles. It doesn't mean accepting inferior quality. Folks who have not gotten a growth mindset, that they want to avoid change, so they may make those straw man arguments. But worse is better really means rejection of complexity, even when complexity is the more theoretically correct approach. I'll say that again. Worse is better really means rejecting complexity, even when that complexity is theoretically a more correct approach. Now, the moment my fellow engineers are asked to choose simplicity instead of some high priest holy notion of engineering, they react as though it's the end of the world. Some are even ready to slap their resignation on the table and walk out. Here's some ideas that engineers I've met are ready to die for. Clean code, secure code, infrastructure as code, open source, test coverage, functional programming, CSS in code, CSS outside of code. And when I say ready to die for, I mean it. They'll shout and threaten to resign when 80% of the code base is open source, test covered, functional, clean, inside, outside, whatever. And they're asked to make a change to their code that's just going to make it an incrementally 70% less than that previous figure. It's a slippery slope. I'll resign, they say. And usually it's because whatever the issue is, it relates to some past problem that they're fighting in kind of the last war. So they need to not let the perfect be the enemy of the good enough. The practical solution that got shipped is better than an ideal solution that did not get shipped. When you're running up against time, and that can mean time pressure from financial runway, you've got to get practical solutions shipped to customers so that you can get paid, so you can make payroll. So if you've got a startup where those resource-intensive technical tasks, somebody's going to always be working on that big framework, those technical tasks are winning out on a daily basis, then this is the problem that you have. I love this this cartoon from XKCD where they're talking about Docker. And the characters here are saying, man, Docker is being used for everything. And the other character says, story time. Once long ago, I wanted to use an old tablet as a wall display. I had an app and a calendar web page that I wanted to show side by side. But the OS didn't have split screen support. That's the operating system. So I decided I'm going to build my own app. I downloaded the SDK and the IDE and registered as a developer for that platform and started reading the docs. Then I realized it was actually going to be way easier to just get 2 smaller phones on eBay and glue them together with paste. On that day, I achieved software enlightenment. But you never learned to write software. No, I just learned how to glue stuff together that I don't understand. And, Randall's referring to Docker here, because this is one of the elements of software engineering is encapsulation is information hiding and avoiding complexity. The principles above that I've mentioned in an offhand way, they are important, clean code and so on, but those are not absolutes. They don't win on their own. They are principles that inform decisions. The thing is that we don't get to throw the baby out with the bathwater. We don't get to storm off because a pet engineering hobby horse isn't pandered to. The hubris of engineers can drive a company into bankruptcy, and we need to understand the cost of standing on those gold-plated principles. So there's a million ways to misinterpret and argue against worse is better. Some of the arguments that proliferate against it are, mischaracterizing it as against what the framers of worse is better intended. And when I'm talking about the folks that first came up with this principle of worse is better, I'm talking about Jeff Atwood in his blog Coding Horror. Atwood, along with Joel Spolsky, founded Stack Overflow, by the way. Now, the thing is that even if the straw man arguments were true, taking a general approach that is worse is better actually has better survival characteristics than if you constantly choose the so-called right thing, the theoretical perfect solution. So I found this particular argument very difficult sometimes, so I'm going to throw out this engineering example. Back in the day, LAN parties happened with those blue cables that you stretched front to back around your house. And before those blue cables were around, the little hubs and Ethernet segments, there was something called token ring. It's a bit like folks today haven't heard of BlackBerry because it kind of died. Engineers couldn't believe that a phone without buttons was better. And token ring was kind of like that. It was technically better because once you had the token, you had the right to transmit on your segment, and there was no dropped frames in theory. But Ethernet managed by having a cheap network hub, and it echoed out every frame that was dropped onto it on every network card that was plugged into it. So you had this idea of carrier sensing, and this in the diagram above, you've got that box there that says, is some other station transmitting, and is a collision detected? And what would happen then in this the Ethernet algorithm as opposed to token ring is that each network card would be able to figure out that it got that collision, and then it would branch off, as we see in the diagram there, as long as we haven't reached our maximum number of attempts, and then we would fall back by some random amount of time. Now, isn't wait a bit kind of a crappy solution? Lost data, dropped frames? Maybe the folks who built token ring thought so when Ethernet came along, because they were using shielded cables, high-end equipment, and each network point there would wait for that special pattern of bits, the token, to arrive. It was purer, perfect, no collisions. But Ethernet 802.11x was the solution that won. Even though we've got, network congestion once you start getting a lot of collisions. But worse is better in that way because we've got a relatively simple algorithm here. So let's assume we accept that. Let's assume we can manage to persuade some of our engineers. What do we do now? You're a technical leader, you're in a startup, maybe you write code, maybe you don't, but you want your company to survive. The key lesson is to listen for when engineer-driven work requirements are landing in your backlog and they're being justified as a choice between two technical options instead of something based on customer needs. Now remember, customers, those are the folks who are paying you. So listen for that engineer-driven work requirement. Listen for those justifications that are only on technical grounds instead of customer utility. That engineer-driven requirement, when folks are demanding something must be done because of an engineering reason, there's zero projected customer benefit or something vague like, we'll be able to deliver the code faster or we'll have higher quality or whatever. We have to have 100% code coverage, or we have to try for it, otherwise quality suffers. But in fact, with very high levels of coverage, you have so much test code, so much dependency injection, so many layers of abstraction in the code base that you get a bloated, unreadable behemoth with your code, and feature requests take months to complete. You've got this tail wagging the dog type situation. And I've seen that in shops where this sort of purism has really taken root. What about security? All right, you need a more secure solution. Show me the threat analysis. I've written a separate post about over-securing things or using complex technologies for theoretical security threats that could never actually manifest in your particular product. General principles are fine, but what are we actually gaining by encrypting that token for, say, your customer loyalty database when it's already in a secure app sandbox? Are they asking for something because of clean code or functional programming or so-called DX, developer experience? Fine, show me. What's the actual advantage? Once you've got that great developer experience, is that going to really translate to getting features done faster? I don't think so. What is the tangible benefit of refactoring our code base to use the interactor pattern and have 5 million tiny useless little classes that need to be touched just to implement a tiny change in functionality? We need to listen for those pieces of engineer-driven work that are creeping in. And I've already previously spoken about watching the GitHub repository, and that's where you can look out for that stuff happening. You can look out for it landing in there. You should be monitoring your Jira backlog, your Agile backlog, and watching out for it. So here's some quick ways of tokenizing the ideas that I've talked about in this session. I love this one, Yagni. Someone says to you, we need to encrypt the token for the loyalty database. You ain't going to need it. You ain't going to need it. Why is it needed? What's it actually there for? Do the simplest thing that could possibly work. This one, also amazing, kind of comes from the roots of Agile. It's basically saying, don't do that complex thing. Look for the simplistic ways to get something that is good enough. In my opinion, oftentimes engineers love to sacrifice things at the altar of this or that programming paradigm, but the best programs are written so that computing machines can perform them quickly and human beings can understand them clearly. If you've got a code base that's just so dominated by all of these paradigms like dependency injection that it just becomes completely unreadable, then it's going to take a long time to onboard new people. You're going to have so much extra code bloat, and ultimately it just does not serve your customers. So, in summary then, Tech idealism can be a huge, massive red flag. Try to preach worse is better instead of some of these ideas like functional programming. If there's engineer-driven work and there's no customer benefit attached to it, you need to check into that. You could potentially look at doing things like salami slicing it. So somebody wants to build some framework for something. All right, well, you only get to build small pieces of it, and you need to show how it's working to drive additional customer value. If it's not doing that, then why are we spending time on it? What is the actual value for this supposed feature? All right, this has been Totally a Thing. I am Sarah Smith. Thank you for listening, and we'll see you in the next one.